In the next analysis, so we're going to take a look at strategy number 3. So we did 3 strategies. So now we're going to focus on strategy 3. Strategy 3, we started out with 37 as the point at which the future expected revenue from Y class sales will be equal to the definite sale of $100 from Q class. So what we're going to do is to run a sim table, which is an analysis that we've already performed previously. So this is not optimization per se, but we will do that, and then we will get into optimization in the next example. So what we're going to do is to run sim table for Y seats going from 30 to 40. And as you'll see, as more seats are set aside for Y class, the revenue will increase. But it comes at a cost, and that would be the standard deviation. The standard deviation also goes up, so which means the added revenue comes with the risk of, or the downside risk, the band of the bandwidth between the minimum possible value of the revenue and the maximum revenue. Okay, it's larger, and therefore the downside risk is higher. So let's go head on to Excel. So now since we're going to only look at strategy 3, now this does not have strategy 1 and 2 here, so it has only we're going to set it up only for strategy 3. So let's do some color coding here. All right, so that's going to be blue. All right, so we have Q demand and Y demand. Okay, so and we have to truncate on the left side. So we have risk normal. So I'm going to type it out. Okay, risk normal, right? And this is Q class. So E3 comma F3. Okay, and then we have to do the risk truncate. Risk truncate has two values, okay, minimum and the maximum, right? But we have only minimum, there is no maximum, so you put a comma and nothing after the comma. So that means only minimum. Okay, now close parenthesis. So that would be a risk normal, but let's go ahead and round it. Round. Okay. All right. Now I'm going to go into edit mode, copy, escape out, and then here we're going to do E2 and F2 for Y class. Okay, so now we need to set the rest of it up, but before that let's get the sim table set up. All right, so okay, so we have 11 simulations that we have to run, because we're going to run reserved seats for Y class going from 30 to 40. And then we're going to do a risk sim table here, okay, of these values. Okay, so that's going to be our reserved for Y class. Okay, so then available seats for Q class will be that minus what is reserved. So okay, so that's our available seats for Q. All right, then Q sales will be the minimum of the demand and what is available. Now, seats available for Y class is min, I'm sorry, not min, B1 minus the sales, the number of seats we sold for Q class. And then we have min of Y demand and available seats. Then the revenue is Q sales times Q price, which is $100, plus Y sales times Y price, which is $300. Okay. Empty seats will be 100 minus the sum of sales between the two classes. Okay. Okay, the break-even approach, we already discussed it last time, in the previous video. So this will be like 1/3. Actually, we can even say the $100 Q price, $300 Y price, and then the cumulative probability is 1 minus that. Then norm dot INV, that probability, comma, 30 and 10. Oh, actually, we should really be using the cell references, okay, like that. Okay, and here also we need to be using cell reference instead of 100 over 300. Say that cell divided by that cell. Okay, so this is your theoretical answer. Okay. So now you all set everything up, and then now you have to run the simulation and do some analysis.